Hi guys, well welcome to the short asynchronous lecture on annual percentage rates versus effective annual rates. I did note that at the end of our lecture on Tuesday we still had a number of slides left to go. They were really practice problems and applications of the concepts that we had discussed during class. So while I will not revisit all those slides, on Tuesday we will talk about this slide, and I encourage you to spend a few minutes trying to set up this problem and solve this problem. The setting up of the problem is the hardest part of this particular one, and we'll talk about it some more on Tuesday. But try this one. So in this lecture, I'm primarily going to talk about APRs and EARs. So an APR, annual percentage rate, this is what is quoted by law. If you look at your credit card statements, or you look at your auto loans or your home loans, they're going to quote an annual percentage rate. By definition, the period rate is going to be the annual percentage rate divided by the number of periods that they compound that rate. So for example, if I have an APR of 12% and it's compounded monthly, 12 times in a year, I'm going to take the 12% divided by the compounding periods, the 12, and it's going to be 1% per month. That's how we calculate the period rate for an APR. While it is quoted this way by law, it is not the same thing as the effective annual rate. So as you guys can imagine, once you have a 1% rate per month, you are going to end up compounding that interest over the period of 12 months. It's not the same as 1% times 12 in terms of what the effective annual rate is. And the best way to work with this is to actually just do a couple of examples here. An effective annual rate is the actual rate that is paid or received as a result of this compounding that happens during the year. As you can imagine, a 12% rate is not the same thing as a 1% rate compounded, or 12% rate compounded monthly. So let's just look at the formula for this, and then we'll do some examples. So here's my effective annual rate. I'm going to take the quoted annual rate. I will divide it by the compounding periods. How many times are we compounding in any given year? I add 1 to it so I can do the exponent. I will raise it to the number of times I'm compounding, and then I'll talk about the percentage rate by subtracting 1. So whenever we want to do the period rate, we're always going to use the APR, and that's what we're going to use when we're doing the present value and future values. It's the number of periods that will change. So here's the period rate, the APR divided by the number of periods per year. We're never going to divide the effective annual rate by the number of periods. That's not going to make sense. And the best way to look at this is to look at an example. So computing an APR, if the monthly rate is 0.5%, and there are 12 periods in the year, the APR is going to be 6%. And if the semi-annual rate is 0.5%, meaning it's compounded twice a year, the annual percentage rate is 1%. And the monthly rate of an APR at 12%, if it's monthly compounding, is going to be 1%. We already did that piece. We always want to make sure when we're doing our present value or future value calculations that the interest rate and the time period match. So what do I mean by that? I mean that if we're taking a 1%, 12% APR that's compounded monthly, we're going to use the 1%, and we're going to use the 12 as the number of periods. So a monthly period, we need a monthly rate. An annual period, we need an annual rate. All right. Here's where it gets tricky. If I earn 1% per month on $1 invested today, right, I'm going to earn 10 cents by the end of the month. The APR is going to be 12%, 1% per month, 12 periods in the year. The effective annual rate, right, because I'm going to compound this 10%, 1% every month, the compound rate, or what we're actually effectively earning, is going to be 12.68%. 12.68%. So we're going to take the 1.01 to the 12th power, and then we'll subtract out the 1 from that number, and we'll get to the 12.68%. If we put it in a different account and we earned 3% per quarter, our APR is still going to be 12%. But the effective earnings of compounding quarterly will be a total of 12.55%. The effective annual rate is different depending on what the compounding is, even though the annual percentage rate in both of these cases is the same. It's quoted the same at 12%. All right, so you're looking at two savings accounts. One pays 5.25% APR compounded daily, and one pays 5.3% with semi-annual compounding. If you don't understand effective annual rates, you might say, oh, well, 5.3% annual percentage rate sounds better than a 5.25% annual rate. But if we figure out what the effective annual rate is, in the first account at 5.25%, we're actually effectively going to earn 5.39% at the end of the year. And in the second account, it'll be 5.37. So we would go with the first account. The compounding matters. And we saw this when we were looking at, you're going to contribute to your IRA for 40 years, right? The compounding matters in this case. We're going to choose this first example. All right, if we want to buy a new computer system in this case, we're going to make monthly payments. The loan period is for 2 years, and the interest is 16.9% with monthly compounding. So this is a per month. Are you going to use APR or EAR? To do the calculations, we're going to use the APR and figure out what the monthly rate is. We could also calculate what the effective annual rate is here. But to figure out our future value and present value, we're going to use the APR to calculate this. So the number of periods is going to be 24, 2 times 12. The interest rate is going to be the 16.9% divided by 12 periods, or 1.40833, repeating. And the present value is going to be $3,500. And the question is, what is going to be the payments? And the payments will be $172.88. You should make sure that you can get to these. We just wanted, while we were talking about compounding, we just wanted to highlight this difference between annual percentage rates and effective annual rates. And that is it for today.